Welcome. In this video, we'll explore slowly changing dimensions, SCD types 1, 2, and 3, a crucial component in data warehousing and analytics. You'll learn how to implement each type using Databricks and Delta Lake with practical code examples. We'll also discuss when and why to use each SCD type to best handle historical data changes in your business. So let's get started. Let's start by generating synthetic customer data using the Faker library in Python. This helps us create a realistic data set without using any real customer information. Great for testing and demos. So let's create 100 fake customer IDs, names, addresses, and phone numbers, then save this baseline data as a delta table to work with in later steps. Now, let's create our initial dimension table to store SCD Type 1 data. The code simply creates the new SCD Type 1 table from the baseline table. To illustrate how changes are handled, we'll simulate an update where around 20% of customer addresses are changed, or in this case, 26 rows. This updated data mimics real-world scenarios where customers move or details change, setting us up to apply SCD logic in the following steps. Okay, in step 4, the SCD Type 1 update logic runs using a SQL merge statement. When changes are detected in key fields, the current rows are simply overwritten. This approach is straightforward, but because old data is replaced, no history is retained, which is why we see no rows inserted while 26 rows are updated. Moving on to SCD Type 2, this is used when you need to track full historical changes over time. We create a new delta table with extra columns like start date, end date, and current flag to mark active versus historical records. This structure lets us preserve detailed change history. In step 6, we load our original data into the SCD Type 2 table, setting the start date as today, the end date to a far future date, and marking all these rows as current. Okay, next, let's move to step 7. This is the heart of the SCD Type 2 logic. When updates arrive, if there's a change, the current record's end date is set to the update date and its current flag turned off, marking it historical. Then, a new record with updated data is inserted with a new start date and flagged as current. This way, every change is preserved in full detail. We can confirm that 26 rows are updated and 26 rows are inserted for a total of 52 affected rows. Let's take a look at the SCD Type 2 dimension table, now storing multiple versions of customer records with valid date ranges, giving you the power to analyze changes over time. Alright, SCD Type 3 offers a compromise. Instead of fully preserving history by rows, it tracks limited change history by adding old value columns to the same row. This is useful when you only need to keep track of recent changes, such as last known address or phone number, without maintaining full historical versions. So let's create and populate an SCD Type 3 table that includes columns for current and previous addresses and phone numbers. Let's look at the logic for SCD Type 3 merge here. When an update is detected, the current values move to the old columns and are replaced by new values. This lets you quickly compare current and past data with limited history retention, so no rows are inserted while 26 rows are updated in this scenario. Here, we display the SCD Type 3 data, showing both current and last known values side by side in one table, ideal for simple change tracking. Finally, we run the following code to clean up by dropping all tables to keep your workspace tidy, making sure no leftover data remains after the demo. To wrap up, each SCD type serves different business needs depending on how you want to track data changes. Use type 1 when history doesn't matter and you just want to overwrite data, simple and efficient. Use type 2 when preserving a full history of changes is critical, enabling detailed temporal analysis. And use type 3 when you need limited history within the same record, tracking just the most recent previous values. Understanding these patterns empowers you to choose the right approach for your data warehousing and analytics projects, ensuring accurate and meaningful insights over time. Thanks for watching. Be sure to apply these techniques to manage your evolving data smartly.